Okay, so we've been talking in 3.2 about a surface area. So today we're going to talk about volume. Okay, so I'll just skip over here, grab some of these things here. So we could probably figure out, the volume of this rectangular prism pretty easily, right? I think you know how to do that. A little bit more difficult might be the volume of a cone or the volume of a pyramid. So we're going to figure out how to do all of that. Capacity is another word for volume. So volume is sort of the space inside of an object versus surface area is just the area on the outside, right? So volume, if you had a container, if you had actually a cone container and you were able to put ice cream in it or pour water in it or whatever, it would be how much would fit inside, right? So that's what volume is. So it would be contained inside the shape. So volume is the measure of the space of a three-dimensional object that it occupies. So in your book there you should have this. So the measure of the space that an object occupies. Okay. Capacity is virtually the same, but it is used in a bit of a different way. When we're talking about filling things up, we ask, what is the capacity of this? So it's how much can fit inside. It's just virtually the same as volume, but it's a little different. It says the amount a three-dimensional object can hold. So when we're talking about a cup or a container, we are interested in the capacity, how much it can hold as far as liquid or things inside of it. And volume, sometimes volume is including the outside, like the container as well. So there's a slight difference. For example, if I submerged this thing in water, I would be measuring the volume, right? That's how much displacement the whole thing takes up. If this was hollow and this was the container shape, and I filled it up with something, I would be interested in the capacity, how much it could possibly hold. A slight difference there. Okay. So if we're talking about capacity, usually we're talking about hollow objects, right? Cardboard boxes that can hold things. While we're talking about solid objects, we're talking about the volume that they take up. That's another way to look at it. Okay, so the volume for both a prism and a cylinder, because let's see, let me grab. Okay, so a prism, right? Like this one right here. Okay, this is a cube. That's a square. Prism, and here's a cylinder. Okay, if we're talking about the volume for these right here, the formula for the volume is actually pretty easy. You take the area of the base and then you multiply that by the height. So it's kind of like that area of that base gets extended into the third dimension there to create the three-dimensional volume. Okay, so again, for another prism like this one, take the area of the bottom, multiply by the height. This one is length times width times height. Easy. This one, what's the area of a circle again? What's the formula? Pi r squared. Pi r squared times h. Okay? So that's awesome. Now cones and pyramids are a bit different, but we'll talk about that when we get there. Okay, so example 1, a rectangular prism has a base that is 15 centimeters by 12 centimeters and a height of 20. So if we were to sketch that real quick, okay, it would look something like this. And so how do you draw a three-dimensional prism is you kind of draw the one side and then you just kind of extend from each corner, extend parallel lines that are the same length, and then you can connect those. And that's kind of a quick and easy way to draw a three-dimensional shape. So we'll label this 15 by 12. Let's go 15 here and then 12 on this side, and the height is 20. Okay, so from here, the height down to there. So that's pretty easy. The area of the bottom would be, so the volume is the area of the base times the height, right? So the area of the base would be 15 times 12, and the height is 20. Yeah?
I have a question. When you're writing your formula,
Yeah.
after the A, do you have to put the little b or?
No, not really. It's
Okay.
I'm just saying that's the area of the base. Yeah, you don't have to write the b there, but just AH is good. Okay. Whoops, what happened there? Okay, so yeah, here's their drawing. Okay, very similar. And again, the area of the base times the height, 15 times 12 times 20 would be 3,600 centimeters. Now here's the thing. Notice, please, that when we're talking about volume, the units are a little bit different, aren't they? With area, the units were squared with the area. With volume, they have to be cubed. And it makes sense because this is centimeters, this one is centimeters, and this one is centimeters. So if we've got centimeters multiplied by itself 3 times, that's where the power of 3 comes. Yes?
Can you get it to power 4?
Nope. Power of 4 doesn't have any application in 3D space. We don't have 3D space.
Yeah, 4.
Nope. Can't afford it. Sorry. All right. Now, because volume and capacity are very, very similar, look at this question here. Calculate the capacity of the first prism. Calculate the capacity. So if this was a cardboard box with the same dimensions, the capacity would be the same. So since 1 liter, actually, does it say in liters? Maybe I missed that part. Okay. So, here we go. Volume and capacity are closely related. In the metric system, 1,000 centimeters cubed. We should highlight this as well. Let's not forget this. We should go back here. So 1,000 cubic centimeters is 1 liter. Okay? So usually in capacity, we usually talk about liters or milliliters or gallons or ounces, things like that, right? Or fluid ounces maybe. Sometimes we use the length cubed for volume, and capacity is usually a special set of units. That's another little difference that we usually find. So if you were, if you had a, like if you went out to, some confectionery, some store and bought a 1 liter pop, you wouldn't see 1,000 cubic centimeters on there. You'd see 1 liter, right? So that's, capacity is usually, they usually use little different units as well. But they mean the same thing. So in this case, if we're talking about cubic centimeters and liters, that's this question, then because 1,000 cubic centimeters equals 1 liter, we're going to go 3,600 divided by 1,000 gives us the number of liters. Okay? So if you have centimeters cubed, you divide it by 1,000 to equal liters. Okay? Divided by 1,000 to equal liters. All right, so let's give this a shot here with some build your skills practice questions. So number 1 says, find the volume and capacity of the following regular or rectangular prisms. Chair up here. All right, so the base is 15.7, and we have the other dimension on the base is 18.8. Okay, that's great. And the height is 12.5, so there's 12.5. Well, you don't really need to draw the diagram, but the volume, because this is a rectangular prism, is length times width times height, isn't it? And it's pretty easy. We've got these 3 multiplied together in any order, doesn't matter. And what do we get for a number there, guys? Anybody done that already?
36,895.
Like that?
That's not bad.
Any decimals?
No, it's 0.5.
0.5 is but after that now.
So, sorry, say that number again then?
3,689.5.
3,689.5.
Yeah.
Okay. Now that's going to be centimeters cubed, but that would be how we would express the volume. And the capacity is going to be, should be, let's do that in liters. And so how do we get to liters again? Divide by 1,000. And when you divide by 1,000, you can do that on your calculator. Or you can actually just move this decimal place to the left 3 times. And that's your new number. So 3.6895 liters.
Do you want to speak that exact or like not?
Yep, leave all your numbers in there, sure. That's fine. Okay. Oh, speaking of capacity, I have a coffee here from my favorite place. I wonder what the capacity is on this one. Oh boy, does it say here? I don't think it even says. Boy, they're trying to hide their capacity here. Well, how could we figure out? How can we figure out how much is in this?
That area of the circumference we multiply by the height.
Well, it's not perfectly cylindrical. Nice try. But this base would actually be smaller than this top. So that's but pretty close, hey? Pretty close. Yeah. We could take them. Well, actually, what we could do is we could take the find the diameter of this top and the diameter of the bottom, and find the average. So it'll be a little bit smaller than the top, a little bit bigger than the bottom. Find the average, and then measure the height and multiply the height. I think I might do that, or you could just go on Google. Oh, that's not as much fun. Okay, let's figure out how many. First of all, how many liters do you think this large coffee is?
It's large?
Mm-hmm.
It's like a liter.
You think that's a liter? Does that look like a liter?
It's like almost.
How big is your drink over there? Does it say? Don't know? Do you know how big your water bottle is there? Do you know what it holds? Anybody else have have anything with you that?
No.
Okay. No? Okay, write this down. Ready? Write this down. Here's the coffee question. Okay, so the width of this is 8.7 centimeters. Okay, write that down. 8.7. The width of the bottom is 6.2. So 8.7 and 6.2. 8.7. Whoa. 6.2. What's the average between 8.7 and 6.2? Would you divide them together? What does that mean? You're pretty close. You're pretty close. What we do to find the average is add them together and then divide by
2.
Add them together, divide by 2. Okay. So 7.45. That's the average. So 7.45. So that would kind of like be the diameter of this. What's the radius then? We divide that by 2. 3.725. Okay. So let's measure the height now of this. So the overall height, what's the guess? What's your guess? 14.7. Actually, let's go 14.5 because there's a bit of a, whoa. Actually, let's just go 14 centimeters because there's quite a lip there. So we've got 14.0 centimeters. Whoops, we're going to make that a circular bottom. So we're going to find out, we're going to find out what our capacity is. This is going to end up to be centimeters cubed, isn't it? So how do I do that? How do I find the area of that base? So pi r squared times height. That's the volume of a cylinder. So the area of the base is pi r squared. So it's going to be pi times, what's r? And what's h? 14. Okay? So let's just quickly finish this up. We've got pi times 3.725 squared times 14. That gives us 610 cubic centimeters. 610. That's only, how many liters is that then? 0.610 liters of coffee. There you go. You're dismissed.